Chemistry Made Simple. Today we are going to look at the continuation of our topic, which is redox reaction. In fact, today we are going to look at problem solving. We are going to look at how to solve problems under redox reaction. So you can join me to the board. We have problem solving, and then today we have the first problem. What are the oxidizing and reducing agents in the reaction? And the reaction is given on the board. 2MnO4 minus plus 5SO2 plus 2H2O producing 2Mn2 plus 5SO2 for 2 minus plus 4H plus. Now, let me just give you a very distinctive explanation about this reaction. This reaction indicates that the redox reaction was under acidic medium. So the reaction took place under acidic medium. Therefore, it has been balanced under an acidic medium, of which we want to look at explanation that concerns how to identify oxidizing agents and then what reducing agents. Now let's look at the technical explanation over here. We are going to first look at it. Solution. Now we have this reaction. In fact, we have MnO4 minus, and then it produces Mn2 plus. So let's take Mn as the first compound and then its corresponding product. So we have MnO4 minus, and then the product we have Mn2 plus. Now we have to consider this under oxidation numbers. In fact, we are considering this form of equation under oxidation numbers. That is the effect of oxidation numbers, and then how to identify reducing agents based on the concept of oxidation numbers. So here we are going to look at the calculation of the oxidation numbers. From the reactant side, we can see that we have Mn and then O4. Now, the Mn over here is the central atom. Therefore, we want to find the oxidation number for Mn and then the number also over here. We know that at the product side, the oxidation number is plus 2 for the Mn. But what will be the oxidation number for Mn over here in this compound? That one we have to find it. And for that matter, we all know how to determine the oxidation numbers of the various elements in compounds. So here we have this very simple compound, and then we want to find the oxidation number for Mn. So Mn is the central atom, so it will be represented by X plus oxygen over here, and then oxygen over here is 4, but it's 2. So we have 4 and then times minus 2. Oxygen is minus 2, and then the charge, the overall charge is minus 1. Therefore, we have X minus 8 is equal to negative 1. So we have over here X is equal to 8 minus 1. Now we have X to be equal to plus 7. So we know that S was represented by Mn. So the S over here represents Mn. That is the oxidation number for Mn. Therefore, we can say that the oxidation number for Mn is what? Is plus 7 in this case. Now, what can we say about the oxidation numbers over here? The oxidation number of Mn at the reactant side was plus 7, and then at the product side we had plus 2. Now we can see that Mn in MnO4 minus or MnO4 was +7 and then it decreased. So we have a decrement. So it decreased to what? +2. So once there has been a decrement, we call it reduction. So it means that Mn reduces. So we can say that Mn since the oxidation number for Mn in MnO4 minus decreases from +7 to +2. Therefore, reduction has taken place. In Mn. So this means that reduction has taken place in Mn. Now, hence Mn is an oxidizing agent. Since Mn is reduced, then it's an oxidizing agent. So hence Mn is an oxidizing agent. Now let's make the next. This time I'm going to make SO and then that. So we have SO2 produces SO4 2 minus. Now we want to check for the oxidation numbers for the central atoms. In SO2, the central atom is S, sulfur. Here too, in SO4 2 minus, this anion, we have the central atom to be sulfur 2. So we want to look at the change in oxidation numbers for the sulfur both at the reactant side and then at the product side. So the central atom is S. So S plus 2 into bracket minus 2, and the whole charge is 0. There is nothing here, so it's 0. So you have S minus 4 is equal to 0. So S is equal to plus 4. This indicates that S here is plus 4. Now we also have S plus minus 2 times 4 is equal to minus 2. So we have S is equal to minus 8 is equal to minus 2. So S is equal to 8 minus 2. Therefore, S is equal to plus 6. So within this reaction to, this is what we can conclude on that reaction. Now, since S in SO2 since the oxidation number of S in SO2 increases from plus 4 to plus 6. Therefore, oxidation has taken place. Oxidation has taken place in S. So oxidation has taken place in S. What does it mean? Hence, Hence, S is a reducing agent. So we have S being a reducing agent. Now, once oxidation has taken place, then it means that the substance over there is oxidized. And once the substance over there is oxidized, then reduction, in fact, we know that it's a reducing agent. Then it means that that substance is a reducing agent. So technically, that is the solution to the first problem. Now let's look at the second problem. Let's look at the second problem. You'll pick it from our book. The second problem. Now that is our second problem. Consider the reaction represented by the equation SO2 plus 2H NO3 plus H2SO4, producing H2SO4 plus 2NO2. Now this is a very simple one, and the question is explain why the reaction is classified as redox. So we have to explain why this reaction is classified as redox. Now let's look at something technically over here. Now in this reaction, we want to identify reduction process and then oxidation process. We want to verify whether oxidation process and a reduction process occur simultaneously in this equation. If it does so, then it means that the reaction over here is redox. But if reduction alone takes place over here in this equation or in this reaction, then it means that the equation cannot be classified, or the reaction cannot be classified as redox. Also, if only oxidation occurs in this reaction, then what we want to also conclude is that it is not redox. So under redox, we know that oxidation process and the reduction process must occur simultaneously, and then that is what we look for in this reaction. Therefore, let's go to the board to verify whether that is what will happen over here. So we are going to look at the first two sides of the equation. So I'll pick SO2 producing H2SO4. With these two, we are going to use the application of oxidation numbers. So we are going to look at sulfur and then sulfur at this side. Now, in calculating the oxidation numbers, we have already done one in the first part of the problem. That is, in fact, we will not go through that tedious workings again. We just want to look at it from this side. Now, we have SO2. So the oxidation number for sulfur, this one minus 2 times 2 minus 4, so it will be plus 4. So sulfur will be plus 4 here. And then in this one we have 2, and then central atom S, and then we have minus 8, and then minus 2, so we have plus 6 over here. Now what can we say, or what can we conclude over here in this reaction? Since the oxidation number of sulfur in SO2 increases from plus 4 to plus 6 in H2SO4. Therefore, oxidation has taken place. Now, oxidation has taken place. Let's also look at the other side of the reaction. We have HNO3 producing NO2. Now, what can we say over here? Let's look at the oxidation numbers. The oxidation number over here for that will be H and then S minus 6. This is plus 5. And then that one will be S minus 4. And then so it's plus 4. So we can say that since the oxidation number of N in HNO3 decreases from plus 5 to plus 4. Therefore, reduction has taken place. Now we have oxidation and reduction taking place at the same time. So what can we say? Conclusion. Therefore, since oxidation and reduction occur in the reaction simultaneously, then the reaction is classified as redox. Thank you so much. Today we have come to solve these two problems so that it will enlighten you on the application of the oxidation numbers in identifying both the reduction process and the oxidation process. See you in my next tutorial. You are highly welcome to Chemistry Made Simple. Bye bye.